Finishing off lesson 5.6, completing the square, we're going to go ahead and take these three equations and we're going to solve them by completing the square. And so there's a few steps that go into this. We're going to take the concepts we just talked about and try to solve these. So what we had before, we don't want this 11 here. We only want our squared term or our quadratic term and our linear term. And in fact, this one's good because the coefficient's 1. It's not 1 over here or here, so we're going to have to manipulate that sum. But what we want is we want the squared term over here and the linear term, but we have to subtract 11 for both sides. So first thing we do when solving by completing the squares, we get the x's on one side and the constant on the other. And what I'm going to do here is I always leave a gap because we're going to have to add something in there. And so this is where the idea from the first part of the lesson comes in. We have to take half of 10, which is 5, and square it. So we're going to add 5 squared. Now, we're dealing with equations. We can't just add 25 to one side of the equation. We have to keep it balanced, so we add 25 over here. The reason we do this is because now this factors into x plus 5 squared. And this is going to equal 25 and negative 11 is 14. And now we can continue to solve. So we take the square root of both sides. Remember, when we take the square root of both sides, we need to put plus or minus. And so once we take the square root, that simplifies with the squared. So we have x plus 5 equals, the square root of 14 doesn't simplify at all, so we're going to leave it as plus or minus the square root of 14. 14. And then we're going to subtract 5 from both sides to solve for x. And oftentimes when we do this, we like to write the rational part first. So we put the negative 5 first, and then plus or minus the square root of 14. So that was our first go of solving an equation, a quadratic equation, by completing the square. All right, these next two have a little bit of a different twist to them. The first step still is to get the terms with x on one side and the constant on the other, so we would add 14 to both sides. Squeeze that in there. So we have a 14 here. Now this one's different. I mentioned this in the last one. This has a 3 here. We don't want a 3, we want a 1. Well, how do we do that? What we're going to do is we're actually going to factor this 3 out of these two terms. So factor 3 out, we get x squared. An easy way to remember factoring is you're just dividing each of these terms by 3. So 18, factor out of 3, you get 6. Over here we still have 14. And now we go to this idea of completing the square. This one has a little bit of a twist on it. We still take half of 6, which is 3, and we're going to square it. So 3 squared, which is 9. But we notice this 9 is inside these parentheses here, and what's on the outside is a 3. So this 3 is distributed to each term in here. So when we put a plus 9 in here, we actually added 27 because 3 times 9 is 27. In order to keep our equation balanced, we have to add 27 to this side also. So after doing that, we have 3. This trinomial factors into x plus 3 squared. That's why we added that 9 there. Equals, and then 14 plus 27 is 41. We can go ahead and solve now for x. We would divide both sides by 3. And that gives us x plus 3 squared. And this doesn't divide, so I'm just going to leave it as 41/3. And then we take the square root of both sides, make sure we put plus or minus as square root of both sides to cancel out that square root. And this is going to be x plus 3 equals plus or minus the square root of 41 I'm going to write it like this, square root of 41 over the square root of 3. The square root of a fraction is the square root of the top or the square root of the bottom. We have learned in the past that we can't leave it this way, so remember we multiply by root 3 over root 3. That's just simplifying this. So we have x plus 3 equals plus or minus root 3 times 41 is 123 over the square root of 3 times the square root of 3 is just 3. And now we can subtract 3 from both sides to finish this off. And we get x is equal to, again, we like to put this negative 3 first, plus or minus square root of 123 over 3. And there's our solution to that quadratic equation. We factored out the 3, we added the 9, which was really 27 to complete the square. So we continued solving. We had to remember not to leave a square root in the denominator, so we had to use this little process here called rationalizing the denominator, and then we were able to finish solving. So let's look at this last one. Can you remember what to do? We add a 1 to both sides because we want to have the x terms on one side and the constant on the other. Then what we do, we factor out a 5 because we want the x squared term to have a coefficient of 1, so this is minus 3x, still equal to 1. We're taking a step further in the difficulty here. We're going to, remember we divide this by 2, which is negative 3 halves or negative 1 1/2, and again I like to leave it as a fraction. So this is divided by 2 is, we're going to add negative 3 halves, but we have to square it. So that is 9/4, but we have this 5 out here, so 9/4 times 5 is 49/4. So we just added 49/4 to both sides. Sorry, not 49, 45/4 to both sides. Or to this side, so I have to add it over here. There's a lot of steps in here, but don't get too mixed up. We're actually just working with numbers, doing things we've done before. Now that we add this in here, this is going to be a perfect square. It's going to be x minus 3 halves squared equals, and this 1 here, we need a common denominator, so we're going to multiply that by 4 over 4, so we have a common denominator. Hopefully you can see this green okay. So this is 4/4 plus 45/4, which turns out to be 49/4. So we have 49/4. All right, now we want to get rid of this 5. I would normally say divide by 5, but since we have a fraction over here, when dealing with fractions, instead of dividing by 5, it's often easier just to multiply by the reciprocal. So we're going to multiply both sides by 1/5. That will cancel this 5 over here. And then we're left with x minus 3 halves squared equals 49/20. Again, we're just following the steps through. We're getting some ugly looking things, but we take the square root of both sides now because we want to cancel the squared. Plus or minus. And that gives us, on the left side, we just have x minus 3 halves because the square root cancels with the squared. On the right, we have some simplifying. We have the square root of 49 over the square root of 20. And we're just going to do a little side note here to help us simplify this. So we have square root of 49 over the square root of 20. Well, we know the square root of 49 is 7, so that works out. Square root of 20, remember what we did here is we factored this, so 20 is 4 times 5, I'm in trouble writing today. 4 times 5 and 4 is 2 times 2. So we have 7 over the square root of 2 squared times 5. And so this is 7. The square root of 2 squared is just 2. The square root of 5 is still just the square root of 5. We can't leave a square root of 5 down there. So we multiply top and bottom by the square root of 5. And we get, finally, the simplified form, 7 times the square root of 5 over 2. Actually, not the simplified form yet. 2 times square root of 5 times square root of 5 is 5. And so now we have 7 times root 5 over 10. Just in case you're wondering, no, you cannot reduce 5 with 10 because 5 is in a square root and 10 is not. So we did all this stuff in the black here to simplify the square root of 49 over square root of 20. So we have x minus 3 halves equals plus or minus. We simplified this and we got 7 root 5 over 10. And now I need to add 3 halves to both sides. So we add 3 halves to both sides to solve for x. And we get down to our answer of x equals, we'd like to put the 3 halves first, so 3 halves plus or minus 7 root 5 over 10. And there's our answer. Just so you know, sometimes they will get a common denominator here of 10, so you would need to multiply top and bottom by 5. And they'll get a common denominator of 10, which would give 15 plus or minus 7 root 5 all over 10. But I like this answer here. So there is our answer. So there are some examples of solving quadratic equations by completing the square. Our difficulty increased as we went across here. I know this looks like a lot. Take it a step at a time, follow the steps, and then we had to do some simplifying. So really the simplifying is the part that took a little longer. And that is solving by completing the square, which leads into what we'll learn next lesson, using the quadratic formula, which is easier to do, but if we didn't know how to solve completing the square, we wouldn't even be able to have the quadratic formula.